so question 15 is the common cumulative frequency curve question. So it tells us that Harry grows tomatoes, and this year he puts his tomato plants into two groups, A and B. He gave fertilizer to tomato plants in group A, and he did not give any fertilizer to the tomato plants in group B. He weighed the 60 tomatoes from group A, and we've got a cumulative frequency graph to kind of illustrate the information. So we can see roughly around here, around 10 tomato plants had a weight of around 163. Okay. Use the graph to find an estimate for the median weight. Well, if there was 60 tomatoes in the group, the median is going to be the middle, so it's going to be at 30. Remember, because we've got a large data set, we don't really need to worry about what is exactly halfway between it with 60 plants. It's actually between 30 and 31, but we don't need to get bogged down in that. 30 is the middle. And we can see that the median weight, reading across and down, is 170 grams. So 170 grams. Okay, it now says that the 60 tomatoes from group A had a minimum weight of 153 and a maximum weight of 186. Use the information and the cumulative frequency graph to draw the box plot for the 60 tomatoes from group A. Okay, well, let's start with the maximum and the minimum. The minimum is 153. So that's 150, that's 160, that must be 155, 51, 52, 53. So that's our minimum. The maximum was 186, 185, 186 there. We also know the median value. The median value is 170. And the last piece of the puzzle, I need the lower quartile and the upper quartile. So if 30 is the median, that means the lower quartile is going to be at 15. So reading across and down. Lower quartile. And the upper quartile will be at 45. Across and down. And that's our upper quartile. Okay. Right, lower quartile is 165. And let's write that down actually. 165. Upper quartile, 175. Nice and handy. And then you complete the box plot. So 165 to 175. And then don't forget to connect your whiskers. Right, that's part B done. Next part, it says Harry did not give fertilizer to tomato plants in group B. He weighed the 60 plants and he drew a box plot. And we're asked to compare the distribution of the weights from tomatoes from group A with the distribution of weights from group B. Compare. Right, when we see compare, we want to comment on an average and a measure of spread. So an average, mean, median or mode, and a measure of spread, either the range or the interquartile range. Okay, so let's have a look at the median weight. Well, we can see in group A, the median weight is 170. In group B, is 162. So you can say, on average, tomatoes in group A were heavier. This can be seen by the higher median. This is seen in the bigger median of Group A. And then a measure of spread. Well, the interquartile range here is actually smaller than the interquartile range here. I think, let me just check. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Yes, it is. It's slightly smaller, which means that the tomatoes in Group B had a more consistent weight. Or in other words, because the interquartile range is greater here for Group A, that means that the weights are more spread out, which means that they're more varied. So the weight of the tomatoes in Group A is more varied. And just to give the reason, this is seen in the more spread out interquartile range. So there's a comparison. We've commented on an average, we've commented on a measure of spread, and that's the question answered.